Alright guys, welcome to this page of the notes. We're going to go ahead and try a couple more of these problems where we are graphing a quadratic already given to us in vertex form, which of course requires us to identify the values of a, h, and k, which I can easily do when it is in vertex form. My a in this case is a -2, my h is a +2, and my k is a +1. What that's going to do, h is the opposite, so since h is a +2, I'll shift in the negative direction 2 units, and k tells me that I also need to shift up 1 unit. So my vertex is now going to be at -2, +1, which puts me right there. I just need to get a couple other points, and actually this is going to be relatively easy to do. Here's why. I know that my axis of symmetry is going to run right down through my vertex. All right, well, I'm going to go ahead and do a -1. What if x is equal to a -1? Well, I plug a -1 in. -1 plus 2 would be a +1. +1 squared would be a +1. +1 times a -2, -2. And -2 plus 1 be -1. So I should have a point at -1, -1, which would be right there. But since this is my axis of symmetry, I'll also have a point right there. Let's try one more. What if I were to plug in a 0? Well, I plug in a 0. 0 plus 2 is 2. 2 squared is 4. 4 times a -2 would be a -8. And -8 plus 1, -7. I just found my y-intercept. 0, -7. But since this is my axis of symmetry, and I am 2 units away from the axis of symmetry, this guy right over here would also be a point, and we can sketch a graph of our parabola. And exactly what we expect to happen has happened. My parabola has been vertically stretched, right? It looks a little narrower than a standard parabola. As we would expect, the value of a was a -2. And we know any number greater than 1 is going to vertically stretch that parabola, plus the fact it's at -2, which means my parabola should open down. And it does. Let's go ahead and try another one. I have a quadratic for you here in vertex form, which means we need to identify a, h, and k. A is 1/2. H, -3, and k, -2. Here's what that's going to do. The -3, well, h is the opposite, so it's going to shift it 3 units in the positive direction. The -2 will shift it 2 units down. So my vertex is going to be right there. And I'll just draw my axis of symmetry right down through my vertex. Now I just need to get a couple other points, which I can easily do. And I'm just, again, randomly choosing points like x equals 1. That's pretty easy to work with. If I were to plug in a 1, 1 minus 3 would be a -2. -2 squared is going to be 4. 4 divided by 2 would be 2, and 2 minus 2 would actually be 0, right? Did I do that right? 1. It's going to be a -2. -2 squared would be 4. 4 divided by 2 would be 2. And 2 minus 2 would be 0. So yeah, that's going to be 0. 1, 0. There. It's an axis of symmetry, so it would also be right there. Same distance on the other side. What if I were to put in a... How about a -1? If I plug in a -1, and again, I'm just choosing these values of x kind of at random, -1 minus 3 would be a -4. -4 squared would be 16. 16 divided by 2 would be 8. And 8 minus 2 would be a +6. -1, 1, 2, 3, 4, 5, 6. Again, this line represents my axis of symmetry. I am 1, 2, 3, 4 units from the axis of symmetry. So 1, 2, 3, 4 units from the axis of symmetry on the other side. That's more than enough points. That parabola is going to run right up through there. And it does look like I would expect it to. My A is positive, so my parabola opens up. It's a negative. It's a positive 1/2, which means a vertical compression. And my parabola does look like it's slightly wider than it would be if A were just equal to 1 and it were a standard parabola. Guys, that takes care of all the problems here in this section of the notes. Hopefully at this point you feel very comfortable doing two things. First, putting a standard quadratic equation into vertex form. And then second, kind of with our review of everything we did with transformations in Chapter 2, Section 7, where we use vertex form to identify A, H, and K. And then once I know what A, H, and K are, I perform those transformations on the parent function to graph the quadratic given to me in vertex form. I had a lot of fun doing this with you guys. Thanks so much for joining me. I'll see you next time.